All right, so today we're doing Lab 9, the Chemical Reactions Lab. So I'm going to go through these. I'm going to show you the appearance of each reagent that we are using so that you can record your observations there. And then I will show you, after I mix those two reagents, what the reaction itself looks like so you can record those observations as well. So let's start with the first reaction. So the first reaction, we're going to be taking a solid piece of magnesium. Okay, and the important part is that it's shiny. We want it to be shiny so that we know that there's no magnesium oxide layer on it. So it's a shiny piece of magnesium, so it's good for the reaction. So I'm going to take this piece of magnesium, I'm going to place it in the test tube, and then I'm going to add HCl to it. So just so you can note the appearance of the HCl, notice it's clear, it's not cloudy. Okay, so I'm going to add this HCl to the magnesium, and then we'll get you a close-up here so you can see what's happening. Okay. Notice magnesium's bubbling. So what you can figure out is, what are those bubbles? What compound or element or molecule? And we'll come back and we'll take a look at this one in a little bit, because this takes a few minutes to fully react. So notice when we started, there was a solid piece of magnesium in there, and then we added hydrochloric acid to it. All right, so I'm going to set this one to the side, and we'll come back and take a look at it again towards the end. Now the next one we're going to look at is taking aqueous potassium iodide. So this is what the aqueous potassium iodide looks like. So if you remember, aqueous is just a solid dissolved in water. Okay, so we have an ionic compound dissolved in water, making it an aqueous solution. So take note of the appearance of this as well. Notice it isn't cloudy. And then we're going to be mixing that with lead nitrate. Let me find my lead nitrate. So here's my lead nitrate, or lead 2 nitrate, I should say. It's a transition metal, so we need to make sure to...
It's in the group.
All right. So now I'm going to take a larger test tube here, and I'm going to add both of these aqueous solutions together. Mix them together and see what chemical reaction happens. So I'm adding first my potassium iodide. And I'm going to take the squirt bottle here of my lead 2 nitrate and add that as well. And notice what happened right away. Right? Both solutions initially were clear, no cloudiness. Now when I mix them, you immediately see cloudiness. That yellow cloudiness is a precipitate coming out. All right. So that is the second reaction, lead nitrate and potassium iodide. So let's look now at the last reaction. So we're moving down now to the third one. We're going to take copper sulfate, aqueous copper sulfate, and aqueous sodium hydroxide. So let me move these aside. And I have both of those right here, labeled very clearly for you. So the copper sulfate, copper 2 sulfate, sorry, being the blue, clear blue, and then the sodium hydroxide, clear colorless solution. So I'm going to get a new clean test tube, and I'm going to mix these two together. I'm going to start by adding some of my copper sulfate. And then to that, I will add my sodium hydroxide. So let's see what happens in this double displacement reaction. Yeah, just a few drops. You can see it's getting cloudy. Right? So that cloudiness is actually a solid for me. Even when I move it, you can tell it's not really moving because that solid is clogging up the space. All right, so this was the third reaction with copper sulfate and sodium hydroxide. Now before we end this, let's go back to the first reaction. Hasn't completely gone yet, but notice it's still going, right? This is the solid magnesium piece with the hydrochloric acid. You can see it's still bubbling. And if we waited long enough, we'd actually see that magnesium, that solid piece of magnesium, would completely disappear. And it's not a magic trick, it's just reacting and forming a new compound and becoming in an aqueous solution. But that is for you to predict and figure out. All right, and that is for experiment 9.